it's very important that we know that the derivative gives us the slope of the tangent line at a particular point on the function. And since slope being equal to 0 represents a point on the curve which has a constant rate of change, that will always give us a point when the slope is 0 will indicate points where it has a horizontal tangent line. And so let's just do an example where we're looking at a function to try to see if we can figure out where does it have horizontal tangent lines. And again, in chapter 2, we'll revisit this idea as we refer to these as critical points, and they indicate minimums and maximum values. But basically, we could always start with our function and take the derivative. So in this case, f prime of x is what I want to find first. So the derivative of 2/3 x cubed, I need to drop the power. 2/3 times 3 would just be 2, and subtract 1 would leave me with 2x squared. And then with minus 5x squared, I would drop the 2, which would be 5 times 2 is 10. And then subtract 1 from the power. So basically, my function here would have a derivative function equal to 2x squared minus 10x. And then what it asks me to do is solve where f prime of x is equal to 0. Basically, what I could do is I could take that entire function and just, and set it equal to 0, and this will create an equation. And if I can solve this equation, I can figure out these points of interest. So a lot of times we might need to use factoring to do this, but notice that there's a common factor of 2x amongst these two terms. So I could factor that out. And again, since I have a quadratic, you could use the quadratic formula to solve this as well, or something else. But in this case, factoring out 2x will be the easiest way. And this will leave me with 2x times x minus 5. And by the product of zeros property, this gives us two separate zeros. Basically, we then want to know, well, what are each of the zeros? Either one of these factors, if either one is 0, those will give us both answers to this equation, which there are 2. But yeah, basically, if I plug in 0, one solution would be x is equal to 0, because that would make the first term, or the first product 0, the first part of the product. And then in the second part, x is equal to 5 would be the solution to that part, because 5 minus 5 is 0. And basically, I find the two roots of my derivative, which are 0 and 5. And basically, these two locations would be the points which we have horizontal tangents. And again, we'll define these to be called critical points later. But let's just go ahead and check the graph of a function to see what this looks like. So we could always start, and this is another way to find points like this. And, I could use calculus and algebra to do so, but I could also look at the graph and try to find out where it has horizontal tangents just by looking for minimum and maximum points. So I'm going to go ahead and type f of x into my calculator, graph, and see what I got. And it says to use a different window. I'll go ahead and use that from -3 to 8 on the x-axis and -50 to 10 on the y-axis. And basically what I would see here is the graph of this polynomial function. I'll go ahead and create a little sketch here on our notes. But it looks like it comes up right there, goes back down, and then turns around. But notice that at the location x is equal to 0, which would actually be right on the origin where the function is, notice that that graph has a horizontal tangent which corresponds to a localized minimum value like the top of a hill. And also at the location 1, 2, 3, 4, 5, we get this point, the bottom of the hill. So finding minimums and maximum points has to do with finding horizontal tangents. And of course, we could write the equations of these using the techniques we talked about before. Anyways, wrapping this up, next week in class, we will talk more about what happens if we have a product or a quotient of two functions. How do we deal with those? And actually, so far, all the derivative rules, I would say, have been pretty straightforward. I'm not saying they're easy. You need to memorize them and practice them. But they actually get a little bit more complicated as we progress through the next few sections. And this will be our primary area of focus next week. So live in class, if you want to bring your notes, we'll work on some parts of these, as well as getting into some applied problems and working on the class activity. Anyways, Hope you all are doing well. See some of you in class, live class, and some of you online next week.